Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today we are going to see the subject 3D printing and design. The subject code is CCS 331, Regulation 2021. In the previous videos, we have seen the processes. Today we are going to see binder jetting and slicing. So first of all, we can see about binder jetting. Binder jetting is an additive manufacturing process in which a liquid binding agent is selectively deposited onto a bed of powder to join the powder particles together. First, a thin layer of powder is spread across the build platform. Then a print head sprays the liquid binder only in the required areas based on the digital design. This bonds the powder particles to form one layer of the object. After that, the platform lowers, a new layer of powder is added, and the process is repeated layer by layer until the full 3D object is formed. Since the surrounding powder supports the part during printing, no additional support structures are needed. This binder jetting is commonly used for full color models and metal printing, where further post-processing such as curing and sintering is required to improve strength. Next, we can see the working process of binder jetting. So, you can see the diagram. Here, a thin layer of powder is spread on the build platform. Powder means the metal or sand or ceramic. An inkjet print head selectively deposits liquid binder according to the CAD design. The binder glues the powder particles together, forming a solid layer. The build platform lowers and a new powder layer is spread. Repeat the steps until a green part is formed. A green part undergoes post-processing like curing, sintering, or infiltration to gain strength. Here, green part means it is a fragile initial component formed by bonding powder with a liquid agent requiring curing to handle, followed by sintering to achieve the final density. So some of the key aspects of green parts in binder jetting. So first of all, characteristics. Here the green parts are extremely brittle and porous as they are held together only by a cured weak polymer binder. Next, production process. After the print head selectively sprays the binder onto the powder bed, the build box is often moved to curing oven to strengthen the binder, forming a more robust green component. Next one is depowdering. Once cured, the part is removed from the loose unbound powder, a step that requires care due to the fragile nature of the green part. Next one is quality factors. Green part density is crucial and is improved by higher compaction thickness which reduce voids. So next one is the key characteristics of binder jetting. No laser or high heat during printing. Binder jetting uses a liquid binder to glue powder particles together. Since there is no laser or melting involved, the process avoids thermal stress, warping, or distortion of parts. Fast printing processes. Entire layers are printed at once by spraying binder, making binder jetting much faster than laser-based 3D printing methods, especially for large parts or batch production. Powder supports the part. Here no support structure is needed. The surrounding loose powder naturally supports the printed part during the fabrication. This eliminates the need for additional support structure and allows more design freedom. It's suitable for large and complex parts because there are no heat related constraints and no supports to remove, and this binder jetting is ideal for producing large components and intricate geometries with internal features. Next one is advantages. High printing speed. Here the binder jetting prints an entire layer at once using a print head, not a laser. This significantly reduces build time, especially for large or multiple parts. Can print full multiple parts. These colored binders can be used during printing, enabling the production of full color models. This is useful for visual prototypes, architectural models, and medical models. Then cost effective. This process does not require high power lasers or heated chambers. Multiple parts can be printed together without support structure, reducing material waste and overall cost. Then finally, minimal thermal distortion. Here printing is done at room temperature without heat. This avoids warping and residual stresses, resulting in better dimensional accuracy. So next we can go to slicing. So what is slicing? The slicing is a pre-processing step in 3D printing where a 3D model is converted into thin horizontal layer and translated into machine readable instructions for the 3D printer. So what happens during slicing? The slicer software cuts the 3D model into hundreds or thousands of layers. It generates the tool path for the printer like movement, speed, extrusion path. Some printing parameters such as layer height, infill, print speed and supports are also defined. So next, the steps in slicing. So first to import the 3D model. So we have to import the 3D model into slicing software. Next, we have to adjust the printing parameters. So the parameters are layer height, infill density, support structures and print speed. So layer height means you have to lower the values which improve detail but increase print time. Then infill density. So controls the part strength. Then support structure. It generates supports material for overhanging. Next one is print speed. It balances speed and quality. Next, you have to generate G code. Here, after adjusting the settings, the software slices the model and creates the G code. Finally, you have to send to the printer. This G code file is transferred to the 3D printer via USB or SD card or Wi-Fi. So next, the popular slicing softwares. The Ultimaker Cura, Prusa Slicer, Simplify 3D, Chitubox. These are the popular slicing software we are using. So Ultimaker Cura are free and it is widely used. This Prusa Slicer are optimized for Prusa printers. Then this Simplify 3D is advanced slicing with premium features. Chitubox is used for resin-based SLA printers. So next one is printing file formats. So here some file formats are there. So first of all, STL. STL means stereolithography. That is mostly used and store surface geometry and used in FDM SLA printing. Next one is OBJ, that is object file that supports colors and textures used in advanced modeling. Next one is AMF. AMF means additive manufacturing file. It is an XML based, stores multiple materials and colors. It's used for multi-material prints. Then next one is 3MF, that is 3D manufacturing format. It's for new standard, high detail and compression, used for modern slicing software. Finally, the G code. It contains machine instructions. It will give the final output for 3D printers. Next, which format to use? So there are STL, OBJ, 3MF and G code. So where we want to use this file formats. So a simple and widely supported file need STL file. Then if the model has texture and colors, then object file is used. For high quality modern format, 3D manufacturing format is used. To send the file directly to the printer, then the G code is required. So finally, you can see this. So a CAD file defines the shape, size and geometry of the 3D shape. Next, the CAD model is converted into STL or AMF format, which approximates the 3D shape using small triangles. The STL or AMF file is sliced into thin horizontal layers using slicing software. Then each slice represents one layer that will be printed. Next, the slicer converts the layers into G code, which contains instructions such as printer movement, speed, temperature, material deposition. Finally, transferring the files to the 3D printer, the G code file is sent to the printer via USB, SD card or any network connection. The 3D printing, the printer fabricates the part layer by layer according to the G code instruction. So after printing, the post-printing processes may be required, such as removing support material or sintering or surface finishing or polishing. So that's all. In the next video, we can see Unit 2. Thank you.